But if you remember in the last class, I talked about something called data imbalance issue. I say data imbalance issue is a situation whereby one class is more than another class. That is what you are trying to predict. Some are plenty than others. That is what we call data imbalance. So today, the only thing we'll be doing today is we'll develop a machine learning model, but I'm going to introduce to you how you can handle data imbalance. So that is what we'll be learning today. How to handle data imbalance in a data set. So first of all, let me upload our data set. And the data set we'll be doing today, I want to show you how you can, because there are some situations whereby you'll be given more than one data and they want you to develop a machine learning model. So you will import more than one data set. However, they want you to build a model. So today we have two data sets. The two data sets are talking about the same people. However, they have different information. So first of all, let me import the data set so that we can use the data to so that we can open the data so you can see it. So we have two data sets. One is loan data. This data set is a loan prediction data set. We want to build a machine learning model that will predict whether somebody, when he collects loan, is going to default in paying back. Default means he will waste time in paying back the loan, or he's not going to default. One means the person will delay in paying the loan. Two, a zero means the person will not delay in paying the loan. So that is a little summary of the data set. So these two data are all about the um, loan prediction. That's loan details of a person. However, the features that are in loan data 1 are different from the features that are in loan data 2. Let me just show us by the side. This is loan data 1. Is a CSV file. You can see we have customer ID, we have system loan ID, loan number, approved date, credit date, loan amount, total date, blah blah blah. These are the informations we have in loan data 1. Now let's check loan data 2. You see it also has a different info. Why is it not coming up? Okay, it wants me to download the data set first. So let's just do it here, then we'll exploit. Okay, so first of all, let's read our data. Let's read CSV. The name of our first data. Let's copy the part of our first data. Copy part. So now we're working with two data. So we'll learn how we can join two data and then use it for model development. So I read my two. Now if you check, this is a .xls file. This is not an Excel file. This is similar to a CSV file. This XLX. An Excel file is XLSX. It has another X after this S. That is an Excel file. If it is an Excel file, you say read Excel, not read CSV. But this is not a full Excel file. That is why I pass read CSV. And then this is a CSV file, still pass read CSV. Even if it's a TXT file, you can read a TXT file by saying read CSV. It will still run for you. So let's run them. Sorry, I made a mistake. Here is XLX. Okay, so let's see our df1 dot head. Let's check the head of both data. Let's see the data properly. So as I was saying, this is our df1. You can see it has customer ID and system loan ID. These are all the information it has. It stops here. Now I said we are trying to predict whether person will default in paying back loan or not. But you can see there's nothing like that in this first data set. There's nothing like 1 or 0 where we are to predict. Now let's check our df2. df2 dot head. Now this is our df2 dot head. Now you can see this one has good bad flag. Good bad flag means is what we are trying to predict. It's a flag that tells you good means 1. It means the person will not default. Then if you see 0, 0 means bad. It means the person will default. Now for you to proceed in developing your model, how will you go about that? In order for you to go about that, you need to merge these two data sets. You need to join them to get one data set. And how do we join them? Now, let me show you something. This customer ID is the same customer ID that is being used in this data set. Now, you can see this first customer, 892A817, is finished with 49. You can see here, 8A2A81, and it ends with 49. This one ends with C0, this one ends with E8. You can see this 8E, sorry. Now, if you check, there are some similarities. These ones are for this customer that has 49, 49, 49. You can see. So some of the information are for the same customers in this first table and in this first table. So in order for you to match them, if you have two data sets that have something in common, there is a way you match them. You match them using a keyword called merge. However, there is a way you merge them. Now, I want to join my two data sets. So I'm going to call my new data set DF. This is DF1, this is DF2. So I'm going to call it DF. Now, I want to merge DF1 and DF2. However, I want to use their customer ID so that any data that is not found here, we'll forget about it, or we'll join separate. We'll put it separate. So in order for, now we have two ways you can merge something. We have concat and we have merge. When we say concat means add something to the end of something. So if it is concat, it will first of all print DF1 and then add DF2 under it. But that's not what we want to do. Why? Because DF1 doesn't have what we want to predict. It is DF2 that have. So once you have a data set like that, whereby one will have what you want to deal with and then the other one doesn't have, you merge them. Don't concatenate them. If you concatenate them, you will just put one on top of the other or one beneath the other. That's not what you want. In our case, we want to join them so that the features, remember I told you DF1 have some features, DF2 have some features. So we want all of them to be in one table, whereby if this guy is being seen, all his features, including his loan status, will be included in the data set. So for us to do that, we'll merge. So we'll say pd.merge. Merging is a library that is in pandas. So you merge the two data sets. We have df1, comma, df2. We want to merge. Now, there are two things you need to set. There's what we call how and there's what we call on. Now, what does how means? How means how do you want me to join them? In our case, I want you to join. The how will be inner and the on, I'm coming to on. Now, what does how inner means? How means it should check the customer ID. The customer ID that tally with what is in the other data set. Pick it as a data. So it will check this record, the one that he finds they are in common, it will now join them. But anyone, if you say join outer means check, even if they are not too common, just match them. But that's not what we want. We want our data to correspond. So if you want our data to correspond, exact match that is being found here and here should be picked. You do inner join. So that is why I said join equal to inner. Then on is how do you want it to join. I said customer ID is what they have in common. So that is what you pick. That thing that they have in common that you want to use in merging them is what you pass in this how here. So let's run it. We'll have a new data set. Now let's run our data set.head, our df.head. You will see that the data set now is combined. If you see the former one doesn't have anything like good bad status, which is the one that holds our details. Now if you check, you'll see that the entire data set has been joined. You can see this one has a good bad flag at the end. So that is the first thing we've learned today, how to merge data sets together. Now let's start our model development properly. But before that, we need to drop things that are not relevant. So let's first of all do df.info. Let's see the features that are in the data set. df.info. Now the data set has 21 columns. It has 21 columns. So things like date, customer ID, we don't need all these things. All these date, customer ID, whatever, closing date. We don't need anything date. So we need to drop them. So we need to do df.drop. and then let's pass the features we want to drop. We don't need customer ID. This is one. So copy. So we need to put it in the bracket because there are more than one. Next is this system loan ID. Also, we don't need it. Anything ID, we don't need it. Here we have our customer loan amount, approved date. Anything date, we don't need it also. Approved dates, creation dates, delete this out. Creation dates, loan amount, total due, X, terms, days, close dates. Anything dates should be out. So we have this date also. This we have refer by X. Now if you check, this refer by X has plenty missing values, so I'm going to remove it. We don't need it. Anything refer by, and couple with is an object data type, so we'll remove it too. And first due dates, first paid date. Then we have system loan ID for Y. Loan amount, approved date Y. We don't need this also. Loan creation date, loan amount, total Y, days referred by. This referred by Y also, we don't need it. Okay, so we've passed all the features we don't need. So we set our args is equal to 1, and then comma in place equal to true. So let's run this. So I think we've removed all the unnecessary features in our data set. So our data set now has just 8 features: loan amount X, loan amount loan number X, loan amount X, due date, terms dates. These are the basic information we have. They are just the amount of times the person collected the loan, the amount he collected, how many days is the loan due, and then will he default in paying back the loan or not. That is what these left details tells us. So let me just print it out. Let's see. So you can see loan number, that is how many times he collected the loan. This was the amount. Total due, that is how much he's supposed to pay back. This is a 1 month loan, collected loan, you can see. Then we have a loan on X, we have a loan on Y. That it can be like maybe record from 2 different banks. It's a a loan record from 2 different banks. So they now use it to justify whether the person has a good payment status or not. So this is what is left in our data set, and this is what we want to develop a model to build. So, but before that, I talked about imbalance. So let's visualize to see if there's any imbalance in our data set. So I'm trying to do a Seaborn plot. Data is equal to df. Now remember, I said if you are doing Seaborn, whenever you want to plot a count plot, that is, it will count how many things are here, how many things are here, you use this count plot. So I'm using Seaborn. That was why I used SNS. So let's visualize and see. Now This is an imbalance data. Why is it imbalance? Remember that I told you when we say class imbalance, it means one class has much data than the other. Now you agree with me that the status of people that usually pay back loan in this data set, they are more than those that don't used to pay back. So if I should use this data like this to build a machine learning model, there will be a problem, because the machine learning model will be predicting good more often than bad. Why? Because it learns more from data that have a status of good or a status 1 than those that have status bad. So we are going to handle that as we proceed. So but before that, we need to perform our normal label encoding, because this good bad flag is in numeric form. So we need to convert it to category or numbers. So from sklearn dot pre-processing, we need to import our label encoder. So we now pass the normal way we usually do it. Le will be equal to label encoder. Then we apply it on that column we want to apply, and the name of our column is good bad flag. So this is it. I applied it here, and then we run it. So if we run it, our df.head, now you see that our data has been transformed. Now our data has been transformed, you can see. Now the next step you have to do is, before you handle your imbalance, always split your data. Now there is what we call data leakage. If you remember the other day I talked about data leakage. I said data leakage is when a data that is not supposed to be shown to the machine learning model is being shown. It has like an expo. You are giving your machine learning model expo. Once you give it expo, you are no longer training it to evaluate its performance, because it already saw the answer. So that thing will reduce his performance. He will not be good, because he's not going to learn well on his own. He has already been given access to answer. So now if you handle class imbalance before splitting your data, there's going to be data leakage. So always split your data into dependent, independent, and also split into training and testing before you handle imbalance. Another keynote: always apply class imbalance handling only on training data. Never you add it on testing data. Why? Because of this data leakage I spoke of. Don't apply class imbalance handling on testing data, because if you do that, there will be a problem of data leakage. So you only apply class imbalance handling on training data. So we need to split our data. So x will be equal to our df.drop is the normal way I've taught you, right? Now today I want to teach you a new method. If what you are trying to predict is at the end, of your data, there is a way you can remove it. If it is at the middle, you have to use the df.drop, the normal way I taught you. But if it is at the end, there is a way you can do it. df.ilock. I will explain what this means. This is for x, and then y will be equal to df.ilock. Okay, now let's first of all run it. I will explain what that means. Now you see that in the data that I've removed that good bad flag is not here. And then if I should print the y, you see that that's the one for the good bad flag. Now you can see. Now back here, let me explain. Now in pandas or numpy, it allows you to do what we call slicing. There's what we call slicing. Now what is slicing? This ilock means index location. Anywhere you see ilock, we have lock and we have ilock. Lock is used to identify something based on its name or the roll number. Then we have ilock. Ilock means index location. Now what does index location do? Now index location is usually a bracket separated by comma. This first part, we have, let me say a comma, let me say a dot b. and then here we have C dot D. Please listen to the explanation very well because it applies to both X and Y. Now, this A and B here always stands for row. Then this C dot D always stands for column. You separate them by comma, row, then column. Now, iLoc means I want to use index to locate some data. Now, if A stands for beginning of your row, B stands for ending of your row. C stands for beginning of your column. D stands for ending of your column. Now, let me show you an instance. Let me call one data set df3 should be equal to df.head. I want to show you something. Then let me add some columns here. Now, df3 has only five records in it. df3 has only 5 records in it. Now, I want to show you how to use this iLoc. Now, let's say I want to identify data only from index row 0 to row 2 in this df3. All I'm going to do is, I'll first of all retain my bracket bar. I'll separate it by comma. Then I'll come to the row. I say I want to pick data from row 0 to row 2. So I'll say 0, then dot. 0 means I want you to start from 0. Remember when we are doing for loop for X in range of, is the same thing that is being applied here. So I want you to stop at 2, but I will not say 2. Why? Because if I say 2, it will stop at 1. So I will say 3. I want it to stop at 3. Then comma. This other side I said is for column. Each of these column also have their index. This is at this low number X is index 0, index 1, index 2, index 3, index 4, index 5, index 6, like that to the end. Now let's say I want to bring out just 1 and 2. So it means I want to bring out data from index 0 and index 1. So I'll say I want you to start from index 0, then dot. I want you to stop at index 1, but I can't say 1. I need to say 2. Then I run. You see that it will bring, sorry, iLoc. I put lock. iLoc. Now can you see? It brought out those data for me only from those locations. So that is how iLoc works. So it allows you to specify your role. I want to start from so role to so role. Then I want to stop so column, so column. However, the same way when I was teaching you list, I say if you are starting backward, something start from -1, -2, -3, -4, like that. Okay, what if you want to bring out only one column? Let's say you want to bring out only one column. For instance, let me still print our df3. Let's look for a particular column. Okay, let's say we want to print data that is at this column. Term days Y. So let's calculate its index. Index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7. Now, if you want to print something at a particular index, there's no need for you to write this 0 dot, then this. You just specify the number of the index. I think we said index 7, right? I want to print data. I still want to print only this from this 0 to 2. So my row side, I will not touch it. However, I want to print data that is only at this index. And we calculated this index 0, 1, 2, 3, 4, 5, 6, 7. So since I'm specific, I'm not going to put beginning. I'll just specify that index. So the moment we run it, you see it will bring out data only at that index. Can you see? However, if I'm starting backward, this term days minus Y is at index -2. Why? Because this one is at index -1. This guy is at index -2. So if I'm doing that here, I'm going to put -2 and then I run. You see, we'll still have the same information. Can you see? So that is how iLoc works. So if what you are trying to predict is at the end, you can do the normal way we are doing, where you say df.drop and then you drop that column, or you can use this iLoc to specify. Now, why do I use df.iLoc? Now, why do I use empty? If you want your data to include the entire data that are in the data set, just put ... and leave it on this side. and then the same thing on the other side. Now, why do I put dot dot? If you didn't put anything at the beginning, say normally I said we have A dot dot B. Now, if A, you leave A as empty, it means I want you to start from the beginning. If you leave B as empty too, it means I want you to start to reach to the very end. Now, why do I, after the comma, why do I leave here as empty too? I leave it as empty because I want it to start from the very first column. That is what it means. If you want something to start at the beginning, always leave that side as empty. However, at the ending part, I don't want it to reach to this -1. Remember, I told you if you want to stop at this index, you must put the number here. For instance, here when we calculated this guy's index is index 7. Since we are stopping at index 7, we'll say index 8. But if you are counting backward, that index 8 is the same as index -1. That was why here I put -1 instead of 8. So I don't need to go and be calculating what is the number of the index. Since this is the person I don't want to include, I want to stop at a person before it. Automatically, I know that the index of the last person where I want my calculation to stop will be the index before -1. That was why here I specified -1 for x. But at the beginning, I put empty. Why? Because I want it to start from index 0. I don't know whether my explanation is clear on this, because if you don't understand this very well, it might be a little bit challenging for you to really get it. So we can unmute our mic and talk, should be, in case you are confused on anything I explain. Is there any confusion?
No, no. To me, it's clear. I don't know about that, but for me, it's clear.
Okay. Any other person's contrary opinion? Okay. Since we are all quiet, I mean, it signifies we're on the same page. All right. So from now henceforth, you can start using this, or you use df.drop, any one of your choice. So then back to the y. Just like I told you, df.ilock, nothing here, because we want to include the entire row. Then comma. I told you if you want a particular column, you specify the exact index. So this our good bad flag is at index -1. That was why here I put index -1. And then remember I said always add dot values at the end, dot values. So we run. Now we splitted our data. Next is for us to split it into training and testing, right? So we import our train test split from sklearn dot model selection import train test split. We import our train test splits. Sorry, here should be from sklearn dot model selection import train test split. Okay, you can ask your question.
All right. Sorry, please, but aside this one, you just did one. This I look when I understand it, but I wanted to ask one question.
Okay.
You say you may say something like before we handle data imbalance, we should do what first? Like I didn't really get
Okay,
that
I
place
say
very
you
well.
must do these two data splits. You must do data splitting before handling imbalance. Why? Because you
Okay.
are not to apply imbalance on your testing data. Because if you apply it, there will be data leakage and it will affect the performance of your
Okay.
model.
All right. All right. Okay. Okay.
So that is why
Okay.
I'm doing splitting first. Is after the splitting before we now apply imbalance. We will now apply imbalance handling. So we have split our data into training and testing, normal way we've been doing. So now the next step, now we can now handle our class imbalance. Now class imbalance is handled using a library called imblearn. So you need to install it first. Pip install imblearn. Me, I already have it. So I believe it will show requirement already satisfied. You can see show requirement already. But if you don't have it, you need to install it. So after installing this, you can now proceed. Now we have three methods of handling imbalance. We have oversampling, we have undersampling, and then we have smooth. But for sake of easiness, I will always advise you to use smooth. Now, what is oversampling? Now back to this our visualization here. You can see this class is more than this one. Quick one, oversampling. When we say oversampling is a technique that will increase the small one to meet the big one so that they can be equal. Undersampling is a technique that will reduce the big one to meet the small one so that they should be equal. While smooth is a technique that applies oversampling and undersampling. So instead of smooth to increase bad to 1,400 or reduce good from 1,004 to around 4,000, smooth might drop both of them at 8,000. That is a practical example. Or it can even increase both of them to be more than. That is how smooth works. So smooth is more advisable because for you to use oversampling and undersampling, there are conditions. For you to handle oversampling, you apply oversampling when you have little data sets, and you use oversampling when you have small data sets. Then you use undersampling when you have large data sets. But what in a situation whereby your data is average? Which one will you use? You always use smooth. So to avoid the confusion of when to use this, always use smooth, because smooth is good whether you have large data set or small data set or average. So me, I always use smooth, and that is what I will advise you to always use. For today's class, we'll be using just smooth. I'm going to teach you how to use smooth, and then for now, we'll forget about the rest. Maybe as we progress, maybe one day we might use the other ones, but they are all the same. So now for us to use it, I've installed our library. So we'll say from imblearn dot. Now smooth is residing inside a library called a page called oversampling. It's residing in a page called oversampling. So you say from imblearn.oversampling import smooth. Now the same thing applies with oversampling that I'm talking about. If you want to do oversampling is also in this library. So if you want to use it, all you just do say random oversampler. If you want to use oversampling, you say random oversampler. That is its own name. If you are using if you want to use undersampling, you say imb.undersampling import random undersampler. So that's just the difference. So, but all of them, the application is the same. The only thing that will change is just in the name of the model. So first thing first, after you've imported the library, you need to pass a variable called, I'll call it SM, or you can call it smooth or anything. The same way we are doing when we are doing all this imblearn, we first of all pass, right? So it's the same thing. So now I said apply smooth on your training data only. So you can see the same way we splitted our data here, you do it here. You say, but we are applying only on training set. So you don't apply on X. So that is why you see here I pass X train. I'm not going to pass X test. I'll pass Y train, but I'm not going to pass Y test. Why? Because we apply sampling or class imbalance handling only on training data. That is why you see here we pass X train, comma Y train. Then you say equal to, now you want to apply the smooth. What is the name that we give our smooth? SM. This is the SM. Then dot. Now all the other ones we've been doing before, whenever we want to apply an algorithm, we'll say fit transform. Remember? But if you are doing smooth, it is not fit transform. Smooth is fit resample, because I want to resample the data. I want to balance it. So you say sm.fit resample, and then you pass what and what did you want to resample. Remember, it's our training data. Now, why are you resampling X train and Y train? Because if you resample only Y train, you didn't resample X train, the data will not be balanced. The length of one will be more than the other one. So you need to resample everything that is used for training so that their length will be the same. So you have to resample X train, comma, Y train. So let's run that. It has resampled. Now let's check. We want to check and see whether there is an increment in our data. Now, where did we visualize? Let's copy this code out where we visualized. Let's copy it out. Now, sorry, let me do something here. I will not put dot values first. Let me remove these dot values. Let me just do it normal so that we can see the visualization. So we can see the visualization. Now I'll paste this here. But however, now what we want to visualize is our Y train. is our Y train. Now, can you see now there's a balance? Can you see the former one was having 1004. Now you can see it reduced both of them to 1002. And this bad that was having small data, you can see that now it has been resampled and it also 12,000. Can you see bad is the one that has 0? You can see they are both equal. So this is how resampling works. So resampling will help you to balance your data back to equal length so that you can use it to train your data. Why are you doing that? You are doing that to avoid overfitting. What is overfitting? Overfitting or underfitting is a situation whereby your data we learn to predict one group better than the other. Remember, I told you, I gave you an instance. I said if you use this data to train, you will know how to predict good better than predicting bad. So, but if you handle it, you gave him the same data. So it means it has equal chance of predicting good and it also has equal chance of predicting bad. So that is how you apply your imbalance handling. So I want to believe our class imbalance handling is clear. Now, one more thing, I'm going to apply scaling from sklearn dot preprocessing import standard scaler. Now I've used standard scaler before for us to scale our data. I told you standard scaler will help you to bring a balance in your data set. Maybe if your data set is having some region like this 2000, 12,000, they are numbers, right? Now the scaling, what scaling does is scaling is going to reduce. Oops, my system is about going down. I'm not having lights. All right, so let me be fast. So the scaling, what scaling does is scaling is going to reduce the scale of the data. Maybe this 12,000, it's going to bring them within a range, maybe between the range of 0 to 1, something like that, and use it as a scale. So that is what scaling does. And remember, you also apply scaling only on training data too. You don't apply scaling on testing data. You apply it on training data. Okay, so let me run this code. So we've applied scaling. So now we can go ahead now to build our machine learning model because we've processed our data. So today I will be using random forest from sklearn dot ensemble import random forest classifier. Since it's a classification task we are doing, so we'll pass our model random forest classifier, then we train it rf.fit xtrain, y train, which is the data we have trained. So I'll call it rf pred equal to, we'll now use it to do prediction, rf.predict xtest. So let's train our model. The model has finished training, so now let's check the performance of the model. So we need to import from sklearn dot metrics import classification report. Let's import classification report. So we'll say print classification report of our y test, our rf pred that we did. So let's run it and see the performance of our model. So you can see our model is predicting with an accuracy score of 80%. However, it's not having good prediction on bad flag. You can see the prediction is very low. 0.40% is bad, 11% recall, 11%, F1 score 18%. This is bad. So let's try another model and see. Maybe linear regression from sklearn dot linear model import logistic regression. So let me just copy this and then call it LR logistic regression. Oh, sorry, I didn't put n here. Okay, so our linear model has run also. So let's see its own performance. LR. So let's run. So you can see this one has an accuracy of 82%. However, it is still performing bad here. So we can keep trying different. It's still performing bad on 0. This random forest even has better performance. But in a nutshell, this is how you can handle class imbalance before you use it for your training. So you can keep trying other models like decision tree, support vector machine. Definitely will have a model that will perform excellently well. But so far, random forest is doing relatively well, not bad. It's just that on the 0 is performing a little bit very low. So we need to improve on that. So you keep trying. That is what I think the idea of keep trying and to try to change, because each of these algorithms, they have what we call parameters. So we get to a stage where we learn what we call hyperparameter fine tuning, whereby you be trying different parameters until you get the one that your model is performing very well. Then you pick that as your final bus stop. So I think with this, I'm going to stop here for today's class. I've come to the end of what I want to